let us begin with the next topic in lipid metabolism, that is lipolysis. In the last class, we had discussed how lipids are formed. Lipids are formed by combination of fatty acids and glycerol. And these fatty acids, they can either be taken from diet or they can be biosynthesized. In the topic lipolysis, we are going to see how lipids, when the body requires, lipids are broken down into fatty acids and glycerol by the enzyme lipase, and how or what the fate of fatty acid and glycerol is. Fatty acids are further oxidized or broken down into acetyl coenzyme A. If you will remember, acetyl coenzyme A was the beginner molecule that was used to synthesize fatty acids. Acetyl coenzyme A with malonyl coenzyme A was used to elongate the fatty acid chain. Fatty acids and glycerol combined to form fats, and then these fats could be converted according to the need of the body into either hormones or glycolipids or phospholipids, whatever the need is. The process of lipolysis occurs in the mitochondria, peroxisomes and glyoxysomes. In mitochondria, it specifically occurs in the matrix of mitochondria, all the enzymes which will oxidize the fatty acids into acetyl coenzyme A, they are present in the matrix. Peroxisomes में भी होता है और glyoxysomes में. Glyoxysomes are present in plants. And what is the function there? The lipids, when they are broken down, they are going to produce fatty acids. These fatty acids are going to produce ATP, and this ATP will be used by these germinating seeds for germination. So they are also used by plants or seeds during germination. Now, because fatty acids are of different types, they can be saturated or unsaturated or odd number, maybe branched. So there are different types of oxidation. Beta oxidation of saturated fatty acids, beta oxidation of unsaturated fatty acids, oxidation of odd number of fatty acids. Odd number means that the fatty acid has 13 carbon, 15 number of carbon, 17 carbon, which is rare. Odd number is rare. Then there can be alpha oxidation, किसकी होती है branched fatty acids की, और omega oxidation where the omega carbon is going to be oxidized. In our syllabus we only have beta oxidation, and that too of saturated fatty acids. Now the fats, we all know that fats are stored usually in adipocytes. अब एडिपोसाइट से हमने फैटी एसिड और ग्लिसरॉल बनवाना है. कब बनेगा? When there is a stimulus, and the stimulus is the body is low on energy. This stimulus is going to activate this fat globule. How? ये जो protective layer है, this protective layer is being broken down, and the fat globule is then being digested by lipases which are present in the cell. So when the stimulus arrives, this protective layer is being shed and the lipase is digesting the fats in the fat globule. And when the lipase digests the fat globule, free fatty acids are produced along with glycerol. अभी जो फ्री फैटी एसिड प्रोड्यूस हुआ है, इसको मोबिलाइज करवाना है हमने इन द टारगेट सेल और द टारगेट ऑर्गन, जिसको भी एनर्जी चाहिए. Here we are taking the example of muscle. So to mobilize this fatty acid, it has to be transported to the blood vessel. From the blood vessel, the blood will carry the fatty acid to the muscle. In the muscles, the fatty acid will undergo oxidation, but oxidation cytosol में नहीं होती. It is occurring in an enclosed environment within the mitochondria. So the first thing that our cells need to do is transport the fatty acid which is present in the cytoplasm into the mitochondria. And in the mitochondria, then the fatty acid will be oxidized to produce ATP, electrons, CO2 and H2O. Now let's see how this transfer or transport of fatty acids inside the mitochondria is occurring. If the fatty acid is short in length, then the fatty acid can be easily transported via a transporter inside the matrix. This is outer mitochondrial membrane, this is inner mitochondrial membrane. But this only happens for fatty acids which have 12 or less than 12 carbons. But if the fatty acid has 12 or more than 12 carbons, then the fatty acid needs to be attached to a carnitine molecule and then it will be transported into the matrix. Okay, now let's see how this occurs. Cytosol is going to have the fatty acid, then we have outer mitochondrial membrane, inner mitochondrial membrane and matrix. In the outer mitochondrial membrane, two enzymes are present. First one is acyl coenzyme A synthetase. It is going to help the attachment or transfer of coenzyme A molecule with the fatty acid. And the second enzyme on the outer mitochondrial membrane is carnitine acyl transferase 1. This enzyme, which is present in the mitochondrial membrane, outer mitochondrial membrane, this is going to help in the attachment of fatty acid with the carnitine molecule. In the inner mitochondrial membrane, there is a transporter and then there is another enzyme. The transporter is carnitine/carnitine acyl transporter. So it is going to transport two different molecules. First one is carnitine and the second one is carnitine acyl, which will be carnitine fatty acid molecule. And the third enzyme that is present here is carnitine acyl transferase 2. Outer mitochondrial membrane में है transferase 1, inner mitochondrial membrane में है transferase 2. So these are the enzymes and the transporters which are present. Now let's see how the transport actually occurs. We'll begin from here, which is the first step. First step में क्या हो रहा है? जो fatty acid present है, it is combining with coenzyme A with the help of acyl coenzyme A synthetase enzyme, and it is being converted into fatty acid coenzyme A. In the second step, this carnitine acyl transferase will come into action. How? It will help in the transfer of carnitine molecule onto the fatty acid molecule. So there will be a removal of coenzyme A. हमारे पास क्या बच जाएगा फिर? Fatty acid carnitine complex. Now this fatty acid carnitine complex will cross the outer mitochondrial membrane and enter the mitochondrial matrix via a transporter called carnitine/carnitine acyl transporter. तो यहाँ पे इसका ये transport हो रहा है inside the matrix. Now it is present inside the matrix as fatty acid carnitine complex. Now from this complex we need the fatty acid to be separated. So this enzyme comes into action, the carnitine acyl transferase 2. What it does is it transfers coenzyme A molecule onto the fatty acid and removes carnitine. So here we have in the end fatty acid coenzyme A molecule and removed carnitine, and this carnitine is again shuttled back through the carnitine acyl transporter back into the cytosol. So there are 5 steps. First there will be combination of coenzyme A with fatty acid, then there will be combination of fatty acid with carnitine, then there will be transport of this complex inside the matrix. Then next what happens is separation of fatty acid from carnitine and attachment of fatty acid with coenzyme A, and the last step is shuttling back of carnitine into the cytosol. तो अब हमारे पास fatty acid mitochondrial matrix में present है. So this is now ready for oxidation. Now that the fatty acid is inside the mitochondrial matrix, here it will undergo beta oxidation, which is a 4-enzyme catalyzed reaction. In this beta oxidation, we are taking example of palmitic acid, which has 16 carbons. So हम इसको ऐसे भी लिख सकते हैं. This is fatty acid chain and this is coenzyme A. तो इसको लिख दिया R16. 16 represents the number of carbons and this is present in the mitochondria. Or we can also write it like R12 CH2 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 C double bond O S coenzyme A. This is 12th. These are 12, 13, 14, 15 and this is 16th carbon. So 16 carbon पूरे हो गए palmitic acid के. Also we'll see there are alpha and beta carbon here. This is the functional group. The carbon attached to the functional group is alpha carbon, and the next carbon, the carbon which is next to the alpha carbon is beta carbon. तो यहाँ पे beta oxidation में इस carbon की oxidation होनी है. We are taking example of palmitic acid, 16 carbon fatty acid. तो यहाँ पे the first step which will happen is dehydrogenation. Hydrogenation means there will be removal of hydrogen from this alpha and beta carbon, and this will lead to the formation of double bond. And dehydrogenation occurs in the presence of enzyme acyl coenzyme A dehydrogenase. जो प्रोसेस हो रहा है उसी के नाम का एंजाइम है. And FAT is carrying the hydrogen. The hydrogen carrier here is FADH2. Now palmitoyl coenzyme A undergoes dehydrogenation to produce trans. Trans refers to this position. Enoyl means double bond. This triangle, this represents double bond. And 2 represents the position. This is carbon 1. This is carbon 2. The second position पे double bond present है. Ene also represents double bond. Coenzyme E. This is coenzyme E. Now next step that happens is hydration. H2O will be added. H2O add होगा. There will be formation of alcohol on the beta carbon. And hydration occurs in the presence of enoyl coenzyme A hydratase. Again जो प्रोसेस हो रहा है उसी के नाम का एंजाइम है. Now this transenoyl coenzyme A, this whole compound undergoes hydration to form beta. This is on beta carbon, hydroxy OH acyl coenzyme A. ठीक है. The third step which occurs again is dehydrogenation. एंड डिहाइड्रोजनेशन कौन सा एंजाइम करवा रहा है? बीटा हाइड्रोक्सी, बिकॉज इट विल एक्ट ऑन द बीटा कार्बन. बीटा हाइड्रोक्सी एसाइल कोएंजाइम ए, ये इसका जो रिएक्टेंट है डिहाइड्रोजनेस. अगेन जो प्रोसेस हो रहा है सेम एंजाइम. एंड in this dehydrogenation the hydrogen carrier is NADH and H positive. So this beta hydroxyacyl coenzyme A will undergo dehydrogenation to produce beta ketoacyl. अब beta position पे क्या आएगा? Keto. This is keto on the beta position. Now this beta ketoacyl coenzyme A will undergo thiolysis. Thiolysis में they will be breaking. Lysis मतलब टूटेगा कुछ. वो टूटेगा कैसे? A coenzyme will come and attack the beta carbon. ठीक है. अब बीटा कार्बन पे जब ये अटैक करेगा तो क्या बनेगा? ये COA और या coenzyme A will attach with this carbon and both these compounds will be separated. And this reaction, the thiolysis, occurs under the presence of thiolase. Now दो products मिलेंगे. One will be myristoyl coenzyme A and the other will be acetyl coenzyme A. This myristoyl coenzyme A, you can see that there are 12, 13, 14 carbon. The first compound that we had, जिससे हमने start किया था, that had 16 carbons. तो जो product बना है that is -2 carbon. तो 2 carbon कहाँ गया है? In acetyl coenzyme A. This acetyl coenzyme A can enter the Krebs cycle और एनर्जी प्रोड्यूस कर सकता है. whereas this myristoyl coenzyme A will again undergo beta oxidation. और जब तक इसके सारे acetyl coenzyme A दो करके निकल नहीं जाते तब तक ये साइकिल चलती रहती है. ठीक है. This will again under beta oxidation and acetyl coenzyme can join the other intermediates in the Krebs cycle. Now we talked about palmitic acid oxidation, 16 carbon. So we had started with 16 carbon, फिर एक acetyl coenzyme निकला, 2 कार्बन निकल गए, फिर कितने बचे? 14 का फिर से बीटा ऑक्सीडेशन हुई, एक निकला 12 की फिर से हुई 10 से 8 से 6 से 4 और 4 से कितने? 2 acetyl coenzyme A बने. तो टोटल बीटा ऑक्सीडेशन की कितनी साइकिल्स होंगी कि palmitic acid to पूरा ऑक्सीडाइज हो जाए into acetyl coenzyme A? There will be 7 cycles for palmitic acid, जिसकी 16 कार्बन की लेंथ है. अगर इससे बड़ा होगा उसकी ज़्यादा साइकिल्स होंगी, इससे छोटा होगा उसकी कम साइकिल्स होंगी. ऑल्सो कितने acetyl coenzyme A बने हैं? 1 2 3 4 5 6 7 8 acetyl coenzyme A in 7 cycles. Now we can also calculate कि कितना मटेरियल बना है और कितना मटेरियल यूज हुआ है, कितने कंपाउंड्स यूज हुए हैं. We can calculate it as there was 1 palmitic acid and how many FADs? 7 FAD positive ये वाले. ठीक है. Plus how many NAD positives? इधर 7 NAD positive plus 7 H2O और साथ में ये भी यूज हुआ है coenzyme A, तो 7 coenzyme A और इन सब का प्रोडक्ट क्या बना? palmitic acid से हमें मिले 8 acetyl coenzyme A, FAD से क्या बना था 7 FADH, then NAD से NADH, 7 NADH positive plus 7 H positive plus 7 H2O. अब यहाँ पे 1 acetyl coenzyme A gives 10 ATP, 1 FADH2 gives 1.5 ATP, 1 NADH gives 2.5 ATP. तो जो total ATP यहाँ पे बनता है that is amounting to 108 or 109 ATP. ठीक है, तो एक palmitic acid के molecule से 108 ATP energy मिलती है, which is far greater than when we get from glycolysis and Krebs cycle and etc. of glucose. Now the acetyl coenzyme A, which is formed as the last product, this can have two fates. First fate can be it can enter the Krebs cycle and it will enter a Krebs cycle as acetyl coenzyme A, then will convert into oxaloacetate. This oxaloacetate can be converted into other metabolites, or it can be converted into glucose, or glucose can be converted into other metabolites or other intermediates, or oxaloacetate can be converted into or broken down for energy. This is the first fate. Second fate of acetyl coenzyme A is formation of ketone bodies. Acetyl coenzyme A, 2-acetyl coenzyme A get converted into acetoacyl coenzyme A. Acetoacyl coenzyme A gets converted into beta hydroxy beta methyl glutaryl coenzyme A. This compound gets converted into acetoacetate. This compound breaks down into acetone and beta hydroxy butyrate. These three compounds, they are called ketone bodies because they have ketone groups in them. These three. Now when are ketone bodies produced? They are produced during severe starvation or untreated diabetes. When glucose is unavailable, even the brain can adapt to use ketone bodies for energy. When due to starvation and untreated diabetes, large number of ketone bodies are produced, and the production of ketone bodies leads to acidosis, which is also called ketosis. The pH drops to dangerous levels. So this is the process of ketosis. और जो कीटोन बॉडीज जिनमें बन जाती हैं जिन लोगों में, they have a fruity smell, and this fruity smell is because of acetone. उनके breath में acetone आ जाती है. Now there another topic that you have is gluconeogenesis. Gluconeogenesis is formation of glucose molecules from molecules other than which are carbohydrates. So let's see how this happens. Fats will be broken down by lipase into fatty acids and glycerol. Fatty acids will break down or they are oxidized into acetyl coenzyme A. Acetyl coenzyme A can be converted into oxaloacetate. Oxaloacetate can be converted into phosphoenol pyruvate. Phosphoenol pyruvate can be converted into pyruvate, and pyruvate again can be converted into oxaloacetate. This phosphoenol pyruvate gets converted into 2-phosphoglycerate. This gets converted into 3-phosphoglycerate. 3-phosphoglycerate will get converted into 1,3-bisphosphoglycerate. 1,3-bisphosphoglycerate can be converted into glycerol 3-phosphate. And this glycerol 3-phosphate can be again converted into dihydroxyacetone. जो ये dihydroxyacetone है, it is converted into fructose 1,6-bisphosphate. Fructose 1,6-bisphosphate is converted into fructose 6-phosphate. Fructose 6-phosphate is converted into glucose 6-phosphate, and then glucose 6-phosphate is converted into glucose. अब यहाँ पे जो ये white lines हैं, these ones, they represent reversible reactions, whereas these pink lines, they represent irreversible reactions. और ये जो enzymes हैं, you need to know them. Fructose 1,6-bisphosphatase and glucose 6-phosphatase. You should know them. ये फेट था फैटी एसिड का कि फैटी एसिड से ग्लूकोज कैसे बन रहा है, और फिर ग्लिसरॉल से भी ग्लूकोज बन सकता है. वो कैसे? Glycerol can be converted into glycerol 3-phosphate, or it can be converted into dihydroxyacetone, और वहाँ से फिर से ग्लूकोज मिल सकता है. Another fate of glycerol can be converted into glycerol 3-phosphate. This glycerol 3-phosphate can be converted into phosphatidic acid, and this phosphatidic acid is a versatile molecule. This phosphatidic acid can be converted into glycerophospholipids, or it can be converted into triacyl glycerol, which were making up the TAGs. So this was the fate of glycerol.